Welcome to the next HSC chemistry video looking at the protecting ozone layer. So we've looked at how ozone is important in our atmosphere, in our stratosphere as a UV radiation shield. We've looked at how we monitor those, but now we want to say, well, now that we know that there is a problem, what are we doing as a community, a global community, to protect and lengthen our existence of the ozone? So we know it's diminishing. So what can we do to minimize that degradation? And also what can we do as a society to ensure that we have that for future generations? Well, the first thing we can do is individually we can stop using CFC-based products and also gases that are ozone depleting. On to the second one now, and now we're looking at global or international plan. On to the second thing now, a global international plan. So back in 1987, in Vienna, a variety of international countries met and they put forward a treaty, a dedicated agreed upon plan to minimize the production of ozone destroying chemicals, right? They called it the Montreal Protocol. Okay, so the Montreal Protocol, and that was where they had a treaty to minimize. All right, so it was a treaty to minimize and phase out the production as well as the use of CFCs and halons and other ozone depleting gases. And so they had a time frame on which they had to meet certain targets, and a lot of countries, including Australia, signed that protocol and have had periodic checks to see that they have been doing that. And so that now, it's actually a yearly meeting. You can check it up on the web, where they are constantly monitoring different countries' progression towards phasing out those chemicals and modifying the uses and adding alternatives. So alternatives that we can use instead of CFCs are hydrofluorocarbons. So notice that there's no chlorine there or bromine. So they're hydrofluorocarbons. They're more reactive than CFCs and halons, and that's a good thing because it means that they don't make their way up into the stratosphere. They react in the troposphere, and therefore they're broken down in the troposphere, and they don't reach the stratosphere to then break down the ozone. So we can use hydrofluorocarbons. They have an ozone depleting potential of around about 0.02. If you remember, the ozone depleting potential of CFCs was like 1, 2, etc. and halons was like 10 times that. Here we have 0.02. So you can see, even if they did make it up into the stratosphere, their reactivity is a lot lower in the sense of ozone depleting potential. So that is how we minimize and protect the damage, or minimize the damage, and we protect our ozone layer by individually making choices, not using CFC gases and propellants and stuff like that. But that's pretty much impossible now anyway, because a lot of the newer fridges and propellants and spray cans are not CFC based. Okay, but if there are old fire extinguishers and old fridges and stuff around, we need to get rid of that gas to protect it leaking into the atmosphere. Then there's a global initiative to try and an agreement to try and minimize the production and use with agreed upon targets. So that's it for the ozone aspect of this particular area of chemistry, and I'll see you in the next videos, and make sure that you keep enjoying your chemistry.